Welcome everyone to our presentation on capability building, competition and design, a case study. This is a second paper that builds on a previous paper that's based upon Takahiro Fujimoto's research on the Toyota production system, and more importantly, how Toyota builds capability inside its factories and scales it across the world. I'm Peter Berg, a project executive for DPR, and I reside in Phoenix, Arizona.
And I'm Dean Reed. I work on lean and integration for DPR, and I really am excited about the breakthrough that Shashi and Peter are going to describe to you, because it's very important for our company. It's a set of capabilities that we really want to spread throughout the company.
Hello, everyone. My name is Shashi Sriram, and I'm a pre-construction manager at DPR, and I reside in Phoenix as well.
Our case study is based upon a real project for Arizona State University, located in the north part of Phoenix, Arizona. When we were brought on board for the project, at the same time as the architect, the campus architect brought us into a room together, and he confessed to us that 6 of the campus's large projects were wildly over budget and very late on schedule, and they were having to walk the designs back or redesign. And he told us that this could not happen on this project. It had to stop, and we needed to figure out how to do that, and that he would not allow schematic design to proceed until we proved to him with a high degree of certainty that the program and concept design were on budget. So with that expectation, we knew that we couldn't use traditional estimating and pre-construction processes that yielded the over-design, redesign, and value engineering that most project teams are familiar with. So what we did was we established a vision for what success looked like, and we labeled that our competitiveness criteria, and that's listed here. And a few of the highlights here would be minimize redesign to the greatest extent possible. Some design iteration actually adds value. We want to add value, but we don't want to over redesign. Also, we had to package the costing information differently, the way that the architect and design team designs, rather than by construction system. And also designing to budget. One of the first things that we did, though, because we knew we were going to have to work differently, is we brought the whole team and we flew the whole team to Los Angeles, where the architect's office was. The importance of this meeting is the architect, we had them describe their process from the very beginning, the idea in a design architect's mind, all the way to a modeled object, to understand how they work. And then we showed them how we worked. And by doing this, we found overlaps and gaps in our processes, and we're able to integrate in a much more deep and meaningful fashion to actually make this happen.
So the very first thing that we did was data mining. We used historical data that DPR has been collecting in all our years in construction. And what we do is we use similar type of projects, and in this case being higher ed. We used the same geographical location and also same type of lab percentage in those buildings. And we built this cost model, provided this to the architect and the owner to inform them on what they were tracking based on just their RFP, even before the program was detailed established. The next thing what we did is we planned on doing programmatic costing on which is based on room-based costing information. And for that to be successful, we needed as much information as possible from the designers. So they provided us with good detailed data sheets for rooms. Like the example that you see here, it's a research lab. We can see the proportion of the lab. It gives us the finishes for the flooring, ceiling, the countertops, etc., and also what equipment go in this lab. So this provided us very good data to input in our cost model, in our estimate, that helped us shoot for the target value that we were going to.
Traditional estimating groups cost data by construction system, foundation, superstructure, mechanical systems. But the campus architect, he required us to prove that the program is on budget. And you can't do that by construction systems. So we package the costing information by room and by program type. And in this way, we're able to very accurately and precisely define the cost of the program.
The other way we also packaged was we were able to pull out core and shell away from the interiors after we established the program. And we were able to pull the shell from the core and shell. Showed the architects on what the exterior skin options that they can pursue for their creativity. In this case, the designers would send us 5 massing options at a time, and we were able to provide cost feedback within 24 hours after they sent it. This helped them narrow down to the 5 options that you see from 30 plus massing options that they sent to us. And then we presented this to the owner as something that's within their reach, and the owner was able to select on which direction he wanted to take. This is the detailed estimate that informed all those data there. It was 92 pages because it was room-based, and we were able to package it into program, core and shell, TI, etc., in all the ways that we wanted. It's a very detailed estimate. This showed the architect on how much square foot of ACT they have, what flooring they have, instead of just $1 per square foot that a lot of conceptual estimates have. And this helped them with establishing their targets as well. So the data that we pulled from that estimate went into the spreadsheet. When we saw that we were tracking 20 million plus above budget, we started creating multiple scenarios for the owner to help them bring that back within budget. So some of the options that were presented were reducing the GSF of the building, changing the skin systems, or even shelling some of the interiors to help them get within their budget.
So in the end, by packaging the cost by program and also with the rapid concept design prototyping, we were able to come up with a solution that satisfied the campus architect's requirement that we proved that we were on budget before schematic design would start.
Okay. The other thing, we also helped the campus architects, and the designers were to track how they were going, keep them on track. So we did quantity trending, and we also did cost trending for them while they were doing their SD drawings and their DD drawings to make sure that they were tracking right for the target value that we established.
Fujimoto, a big part of his framework is the idea that capability is built through routines. We established 19 routines to make this process successful. You see projects 1, 2, and 3 there at the bottom. The competitiveness was quite low, but the ACU project, all of a sudden, it jumps up to 85 because we were able to successfully integrate and make all these 19 routines happen at the same time. And then in the subsequent projects, 5, 6, and 7, it dropped a little bit because there were different teams with different capabilities. Also, Fujimoto talks in terms of multiple paths to evolutionary learning. And the 3 key ones here are entrepreneurial vision. And you'll see at the ASU project, it jumped up to 68%. You need the new idea to develop the new process. Knowledge transfer, you'll see it starts at 37%. But afterwards, we borrowed from the ASU project and carried it to 3 others. And then patterns of routine capability on the subsequent projects, we were able to routinize all 19 of those steps consistently. And those 3 things allow for capability building of capability. We look forward to our third paper to further this process, and thank you for listening and enjoying the presentation.
Thank you.